Okay, so when I say, can you solve for a quadratic equation, it means to find the x-intercepts. And the x-intercepts are where y is 0. So this is all about find the x-intercepts. That's a big idea. And it's where y is 0. Do you understand the y is 0? Because, for instance, let's say this was 4. The actual coordinate is 4, 0. Right? Because that's the height of 0. So that's what we're going to be trying to do. Okay. Does this make sense? Sometimes quadratics actually have no solution. Okay, looking at this quadratic, do you see where it's ever going to touch this x-axis? It's not, right? There's going to be no solution to it. Sometimes quadratics can have exactly one solution. So what would be the scenario if the vertex is on the axis itself? And sometimes quadratics have 2 solutions. Okay, and we've talked about this on the first day. You might hear me say, this is a 0, or this is a root, or this is an x-intercept. Remember, all 3 of those words mean the same thing. Okay, so we have a bunch of different methods. So here's the methods. You could factor. You can use a quadratic formula, or you can use your calculator. Okay? When I look at factoring, we have 4 styles of factoring. So here they are: simple trinomial, complex trinomial, GCF, and a difference of squares. You did this in grade 10. Do you remember some of these things? It's been a while. You should remember, because we did it in grade 11 pre-calc. Okay. So number 1 here. I've given you an equation that's actually already factored out. Okay, it's factored. Without graphing, what are the x-intercepts? So if I want to make y 0, if I would like the y to be 0, what number do I need my x to be? Okay, so I want you to think about this. This is something times something times something. In multiplication, how do you ever get an answer of 0? If something is 0 when you're multiplying? So what if I wanted this number, this bracket, to be 0? What would x have to be? Positive 3. Because 3 subtract 3 is 0. And then if that bracket is 0, 0 times anything is 0. And what would I want this x to be? -1. Because -1 plus 1 makes 0. And now it's going to have a 0 times blah, 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 0. Okay. Will this have a minimum or a maximum vertex? So which way does it open? Do you know which direction it's going to be opening in? What am I looking for? I'm looking for the number that multiplies in the front. So what's the number multiplier? A -2. So therefore this opens down, which means the vertex is going to be a min or a max? It'll be a max. Okay, graph it on your calculator to verify what we've done. Okay, so y equals negative 2 bracket x minus 3 x plus 1. Okay, so you need the brackets exactly how I've shown. And obviously this is a baby negative on the 2. And then this is a subtract button, right? I'm going to zoom 6 because I don't know what my window was at. Okay, so I've verified, yep, that's a max, right? It didn't ask for what it is just said, is it a min or a max? So it is a max. And I would like to verify that these are the x-intercepts. Okay, so you know what I'm actually going to do? I'm actually going to go trace 3, enter. Because I already thought it was a 3. So I'm checking it out. Is a 3 the x-intercept? Yeah, because look at it's 3 comma 0, right? And that's what I want. So I'm going to go trace negative 1, enter. Okay, we could have calculated it left, right. We could have done that, but because I already knew the answer, I'm just checking it. Okay. First one. So my point is that I want to make that a 0. And I'm going to factor this. So I gave you the I gave you the 4 styles here. Simple trinomial, complex trinomial, GCF, difference of squares. So a simple trinomial has 3 parts because it's a trinomial, and it would always start with a 1x squared. That's what makes a simple trinomial. Okay, so this is a simple trinomial. So here's your tactics. 2 brackets. What first times first makes x squared? So x times x. Okay, that's what will multiply to x squared. At the end, what times what will give you 20? Now, those 2 numbers that you're going to pick also will have to add to 9 in the middle. So multiplies and adds. Can you think of 2 numbers in math that multiply to 20? Do you have something in mind? 4 and 5? So 4 times 5. To get a positive 20, they both have to have the same sign. So either that they're both positive or they're both negative. So if I want to add to negative 9, they're both going to be negative. So you also know how to do this in math. Can you think about how you would multiply that? First times first is x squared. This is a negative 5x and a negative 4x, which makes negative 9x. And this times this is 20. So that's your original. Okay, so what is the x-intercept? So that would be a positive 4, and this would be a positive 5. Okay, we're going to graph this, but before I graph it, can I ask you this as well? Does anybody know what the y-intercept would be? So these are the x-intercepts to make y 0. So a y-intercept should be where x is 0. So if x was 0, what's the y-intercept? You can do your math really fast. If x is 0, Your y-intercept should be 20. Okay, let's check this out. Clear x squared minus 9x plus 20. Graph. So we had discovered the x-intercept should be 4 and 5. So I'm going to trace 4. Yep, we did it right. Okay, do you see it? 4, 0. And I'm going to trace at 5, and yep, it's also the other one. I'm going to trace 0, and look at that. It would be obviously way up there if I show you. There's my y-intercept that we thought about. Right there at 20, okay? Okay, number 2. It's a simple trinomial. Okay, I can see the 3 parts, and it starts with a 1x squared. Okay, so I'm going to create a 0 for y, and then my tactic is to do 2 brackets. So what times what makes x squared? So x times x. Okay, so we're going to have to think about 2 numbers that multiply to negative 24. And then I know that one of them is negative and one's positive, because that's how you make negative numbers. Those 2 numbers will have to make a positive 5 when I add. Can you think about 2 multiples of 24? You have something in mind that would get you a 5.
3 and 8.
3 times 8. One is positive and one is negative. So I need to play around with the idea of making a positive 5 out of it. So those multiply to negative 24 and they add to positive 5. Okay, so x equals 3 and x equals negative 8. Okay, I'll just do this. You guys don't need to do it because I think you'll be fine at this part. So you don't need to do it, but I'll show you here. So I just plugged it into my calculator and I'm going to trace 3. Does it work? Yep, that was one of them. And negative 8, yep. So we were correct. Okay, the next are complex trinomials. So how do I know something's a complex trinomial? It has the 3 parts, so trinomial, it has 3 pieces, and it starts with some other number, x squared. Okay, so this is a complex trinomial because I see the 3 pieces of it, and it starts with a 2x squared. And same with this. Okay, those examples I'm going to leave for tomorrow because those will take me a long time. So we're going to do the more simple ones today. Okay. Let's actually just talk about these next 2 because we're going to do these. So the greatest common factor is where you can take something common out. So once you remove something that's common, okay, and it's like dividing out, what's left? And the difference of squares will look like when you have a difference of squares, there's only going to be 2 things. Okay? So the difference of squares has 2 things, And there's always going to be a subtraction because that's what difference means. In math, a difference is to subtract. Okay. So this type here is a GCF. So I want to make the y 0. That's the point there. The first thing, the idea is the y has to be 0. Okay, looking at this and this, what is in common? What do both terms have in it? I could divide each term by a what? By an x. Each term I could divide by an x. So that's what's in common. Okay, now I'm going to write what's left. So if I divide this by x, x squared divided by x leaves me with an x. Negative 10x divided by x leaves me with a negative 10. Okay, I always say, why don't you multiply just to make sure it goes back to that. If I multiply this, does it make x squared minus 10x? Do you see the multiplying it back? Okay, so here, if I want that bracket to be 0, x would have to be, what do you think? 0? Does that make sense? If x was 0, that whole bracket would be 0. And here, if I want that bracket to be 0, x would have to be 10. Okay, I'm going to graph it. That's fine if you aren't here. Just to show you. So here's this one. You can see where it's crossing. So it crosses right here at 0 and at 10. That's what it did. Okay, this one is also a GCF. Okay, what is the something that I can divide all of those terms by? What's in common? What do all of them have in common that I could divide each one by? They all are divisible by 2. Okay, so if I divide by 2, this is x squared. If I divide by 2, this is 9x. And this is 18. Okay, I see something else. This is a simple trinomial now, because it starts with a 1x squared. Okay, so x times x, and then the rule is what multiplies to 18 and adds to 9. Two things that multiply to 18. 6 times 3, and it has to be plus. Okay, so now looking at the x's, okay, I don't need to look at this because it's just a constant, so I'm not worried about it. So x would have to be -6 or -3. All right, and again, you can just type away into your calculator and you'll see that. Okay, we'll do these two and then that's it today. Okay, so this one is the difference of squares. Okay, so 0 equals, because I want my y to turn to a 0. Okay, do you see the format? There's only 2 parts and there's a subtract. Okay, so brackets, that's the tactic here. I need an x times an x. I need a what times what to get 16. A 4 times a 4. And how do I make a subtract in math? With a plus minus. Okay, this is technically, you could do the trinomial rules. This is what the difference of squares is really about. Here's the trinomial, right? So you're thinking, what multiplies to 16 and adds to 0? And that's why it's creating a difference of squares. Okay, so here your solution should be -4 and +4. Okay, and that's what it would look like on your calculator. Okay, last one. So 0 equals 2 brackets, because, sorry, it's a difference of squares again. Difference of 2 things that I can square root. Okay, what times what will get you 9x squared? It's got to be the same thing. What times what? Did you pick 3x times 3x? Does that make sense? What times what is 16? 4 times 4, and then you'll have a plus minus. Okay, this one is different. Because these ones just had x's, I could do them quick. This one doesn't just have an x, it has a 3x. So how do I get this bracket to end up at 0? How do I get that bracket to end up at 0? How would you do some algebra stuff here? I'm going to subtract 4 and divide by 3. Okay, I kind of do a little cheat shortcut thing. I always understand in my head this algebra is always that you're going to have to move this number and divide this number. So this is always going to be opposite divide. So what would this answer be if you thought about that? Opposite divide. So this one should be +4 thirds. And I am going to graph that one for you here. Okay, so here's my quadratic. So I'm going to second calculate the 0. I'm going to move my mouse left, enter, right, enter, guess, enter. -1.33. What do you think? -1.33. Do you know your math? Does that match that? Yep. Okay, and if I second calculate the 0, I'm going to left bound it. I'm going to right bound it. So it's between there, 1.33. So I can check, and those match.